Tungsten, netherite, two materials that have nothing in common. Or do they? Tungsten is one of the toughest and strongest metals in the real world, handling the heat and the pressure other metals can't handle. However, could it be upstarted by a material that's not even real? The material in question is netherite, a fictional material from Minecraft, which is found and forged in the intense heat of the nether realm, making it the strongest material in the game. Now, the big question is, which is stronger, netherite or tungsten?
First, let's take a look at tungsten. At first glance, it looks like any other metal with its shiny, opaque, silvery gray color, but don't be fooled. Tungsten is extremely heavy. It's the second densest metal in the world, topped only by osmium. Tungsten is widely used for its malleability, tensile strength, and thermal resistivity. In order to test tungsten's thermal resistivity, we designed and performed an experiment as follows. Heat a hot plate to a set temperature. Place the cube in the center of the hot plate and using a thermocouple, measure the temperature on the top of the tungsten cube as it is heated. This experiment is an example of transient state thermal analysis in which we compare the temperature vs time of an object to find its thermal resistivity. The data shows that the temperature of the tungsten approaches the temperature of the hot plate asymptotically. This is represented by a differential equation, the solution of which follows the form T equals a EBT, where A is a positive integer that represents the asymptotic temperature and B is a positive integer that is proportional to the coefficient of heat transfer. All of this information is found in the document linked below in the description. Using the curve of best fit for our data yields the following equation. T equals 167.9 minus 142.7 times e to the negative 0.9638 t using b equals 0.9638. We can calculate the coefficient of thermal resistivity of tungsten as follows. H equals B times M times C underscore W divided by AM equals 0.311 kilograms. C underscore W equals 133 joules per kilogram times Kelvin. Equals 0.645 meters squared. H equals 618 watts per meter squared times Kelvin. However, this answer does not have the correct units of watts per meter times Kelvin. We must multiply by the length of the cube in order to get an answer with correct units. 618 watts per meter squared times Kelvin times 0.254 meters equals 15.7 watts per meter times Kelvin. In reality, tungsten has a coefficient of heat transfer of 175 watts per meter times Kelvin, so we're off by one order of magnitude. This makes sense. Our experiment lost a lot of heat on the way up as the sides of the tungsten cube were not insulated. This is best illustrated by the fact that the curve of best fit that we determined from our data has an asymptotic temperature of 167.9 degrees Celsius, meaning that we lost nearly 100 degrees Celsius on the way up. This loss of heat makes the tungsten act as though its coefficient of heat transfer is much lower than it actually is. Now that we've analyzed tungsten, let's take a look at netherite and see if it can do any better.
An easy way to test the thermal resistivity of netherite is by simply throwing an ingot, such as this, into the lava and seeing how it doesn't burn. So, throwing it into the lava, give it a few seconds and it will pop back up to the surface and nothing will be wrong. It won't be burning, it won't be doing anything. Let's watch. There it is. Look at that. All fine. Not burning, not on fire, not nothing. It's fine. It resists the intense temperatures of the lava. By comparison, let's say you take a diamond. Okay, let's see, not diamond or somewhere. A diamond and something like, let's say iron. There we go. Throw these in lava. Oh, and that. And they're both gone. They're both gone, incinerated, burnt. This shows how netherite can resist the high temperatures of lava, while like literally no other materials in Minecraft can resist like the high temperatures of lava except netherite, which shows that it can resist the high temperatures of lava, which using real world measurements is a scalding 1250 degrees Celsius. So netherite has insane thermal resistance, right? Well, yeah, but that's not the entire story. Because this is just an netherite ingot. It doesn't display much about the resistivity to heat when like considering how it transfers heat, how heat transfers through it. Uh, there would be further evidence and support like to the insane resistivity, thermal resistivity of netherite by testing how the netherite armor fares in lava, how its thermal resistivity fares in lava. So we'll test that. We'll time how long it takes to die in two trials, one without armor and then one with armor. So the reason we have one without armor is so we have a control group. So and with that control group, it gives us the base time for Steve to die due to getting incinerated by lava. And then, according to a study that we have linked in the description, check it out if you want to. Uh, the thermal resistivity of a human, I don't know why they tested this, but it was measured at approximately 34.3 Kelvin per watt, which allows us to calculate the thermal resistance of netherite using the data found in this experiment. So let's get cracking. So here, as you can see, not wearing any armor right now, not wearing any bit of armor on me. So I will jump into this lava, and then we'll see how long it takes for me to die. So let me set my game mode to survival. Cool. All right, now I'll start my timer as soon as I'm in the lava. So ready? Let's count down. 3, 2, 1. All right, and that was like 3.5 seconds. Cool. So now we know. So without armor, I died in like 3.5 seconds. Except 3.53 to be exact. But yeah, you know that. Now we're back here. Cool. Now let me switch my game mode back to creative so I can get my netherite armor. This, 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 and a bit of this. And let me equip it. Do, do. Care about these anymore. You can also watch that they won't burn as well. It'll take a bit longer, but no, I don't care about this either. Alright, so now, as you can see, fully stacked netherite, right? In full netherite armor. Okay, now I'll jump in. Let me reset the timer. Alright, I'll jump in and we'll time how long it takes to die with just netherite armor. Alright, so here, I count down. 3, 2, 1. Alright. Oh shoot. Uh oh no. I forgot to switch to back to survival. Here, let's redo that then. Let me reset the timer. Slash game mode. Oh, slash game mode survival. Sorry about that. Screwed that up, but that's fine. It's fine. All right, now let's redo that. 3, 2. Let me make sure my timer's reset. Okay, cool. 3, 2, 1. All right. Now let's wait for it to just take effect. Alright. It's doing 2 hearts of damage at a time, but the netherite armor looks to be resisting it. It's not going that fast, honestly. But let's see. Let's see what happens. It's going. It's going. Oh, almost there. Down to like 3 hearts. Oh boy. Oh, almost there. Oh, there we go. 34.15 seconds. That's how long it takes to die with netherite armor. All right, now we have the data. Let's let's go into. I'm gonna make a table, and to display the data, and we can analyze it. So yeah. All right. So let's save our data so then we can analyze it. Let's put it down here in Paint so then we can analyze it. So first things first, the without armor time was approximately 3.53 seconds. All right, and then the with armor time, the with armor time was with with netherite armor was approximately 34.15 seconds. Alright, seeing this, there was a clear difference that I made. Almost like 30 seconds of time like added because how the netherite resisted the heat from the lava, which is very it's really significant. So now how can we find the thermal resistivity of netherite? Well, we have this really neat equation here, which is where we can use the thermal uh, resistivity of Steve in this case, or whatever. It would be whatever object we were testing, but in this case it would be Steve. So we would take resistivity of Steve. Let's see, Steve. All right, and then we multiply this by. Here, let me make this a bit bigger. There we go. And we would multiply this by the time it took. Uh, time of death with armor. All right. Right, so we have that, and then this is equal to the thermal resistivity times the time of death without armor. In this case, for our experiment, this is the equation that will give us the can I get back to this? Well, here, give me a second. This. Can I adjust this or something? Oh, there you do that. All right, whatever. That's fine. So essentially, it's just the thermal resistivity of Steve times the time of death with the armor, and that's equal to the thermal resistivity of Netherite times the time of death without the armor. So here, let's write that down. What do we have for the thermal resistivity of Steve again? Well, the thermal resistivity of Steve, here, thermal resistivity of Steve, make this a bit bigger, is approximately 34.3 uh, Kelvin per watt, because that's what we got from that's what the study said, remember? So yeah, the study said that. So we have that as our thermal resistivity of Steve. So essentially, we can just plug this in and uh, find the thermal resistivity. So modeling after this equation, so it's the thermal resistivity of Steve, 34.3 times the time of death with armor, which is 34.15 seconds, and then set that equal to the thermal resistivity. We'll set that as x times the time of death without armor, which is 3.53 seconds. So we are just solving for x, and we can just do this with common algebra. So here, let me grab my calculator. So what's 34.3 times 34.15. That is approximately 1,171.345, and that's equal to 3.53x. And now, now we just solve for x, and we and then to do that we just divide 3.53 from both sides, and we get the thermal resistivity of netherite to be approximately. Give me a second here. Or divide this by 3.353. It's approximately 301.82577.9. Uh, that Kelvin per watt, I think. Pretty sure it's Kelvin per watt. For the thermal resistivity of netherite. Yeah, because that's the units for C as well. So yeah, there we go. That's what the calculations gave us for the thermal resistivity of netherite. 331.8257779. Just to be exact, after all. So yeah, those are our numbers. And then in our conclusion, we will compare this with what we got for tungsten, and we'll uh, compare this, and then we'll also compare the results of the stress and strain data, and we'll determine which one is stronger. And yeah, that's pretty much it. Well, let's jump back to tungsten and analyze specifically the stress and strain of tungsten, how much stress and strain it can handle.
While thermal resistivity is one core aspect of material strength, equally important is its tensile strength, its resistance to breakage under stress and strain. Of the earthly metals, tungsten ranks the highest, with a maximum tensile strength of 500,000 psi room temperature. In a similar vein, tungsten ranks at a 9 on the Mohs hardness scale, surpassed only by diamond. As a side note, we obtained these results online. We were unable to meaningfully test tungsten in the lab as none of our equipment was able to scratch or dent our tungsten cube. Rest in peace, 1,000 milliliters beaker. However, we were able to get some amateur clips of dropping the cube on various objects, so enjoy those.
3, 2, 1. Oh, we got something.
No, we do it again. We
Again.
gotta get a pop.
Again.
These are the poppy clips.
There, we'll zoom in. Alright, 3, 2, 1. Excellent. Any pops? There's a bit of a pop.
We got a pop.
We got a pop. A pop. 2, 1. Oh my. Whew. Major damage. Look at that.
Alright.
Excellent.
Final take.
Final take? Alright.
One last throw.
Alright. End all be all. Let's see it. 3.
Get the top down.
Yeah, that's what I'm gonna do. 3, 2, 1. Oh my god. Beautiful. It's
Alright.
beautiful stuff. This has been a thorough experimentation of tungsten. Thank you for listening. Let me see that smile. Oh. Oh, hey, look at that. Look at that. Nice.
Yeah. At the very least, we don't have to reset it this time, so we can just throw it.
Yeah. Alright, go ahead. Oh, finally! Oh my god. Beautiful. Right through. It never saw it coming. Oh my god. What a chunk. Beautiful.
You're kidding. I aimed for the middle of the thing.
And this is over. 2, 1. I think we.
That corner, because this one I'm aiming.
I think maybe we get off the ladder.
No, I think we must get one more from the ladder.
Alright, fine. Oh yeah, let's get one more from. 1. Oh my. Oh, that was a devastating impact. Really just penetrated it. Alright, grab this. This. What?
Put it outside.
Oh, on the side? Yeah, oh, that's probably right.
Just want to try it.
Alright. It might bounce a bit though.
Oh, that's why I'm throwing overhand.
Oh, yeah.
Throw it fast enough, it won't bounce.
That's true. Alright. 3, 2, 1. Oh. Seem to have. Huh? Where'd it go? Oh. That is stuck. Okay. 2, go.
Oh, that's what you think.
It is, yeah, it's a lot harder than you think it's gonna be. Here. 3, 2, 1. There we go. Finally. Alright. Look at that. My goodness. Oh, right through. The car would stand no chance. Neither did the pot.
Alright, we go
More
again.
pots. More pots must
This
be.
one now, I'm just gonna overhand throw it.
Alright. Hopefully it still lands dead center. 3, 2, 1. Oh my. Did it go through? Oh, yeah. Still a lot of damage though.
That's a lot of damage.
I hit it. Three, two, one. Miss. Ram. 3, 2, 1. 3, 2, 1.
Good.
3, 2, 1. Okay, I see what's happening. 3, 2, 1. All right, here. 2, 1. You missed. All right, here. Let's redo that. Right here. There you go. All right. Take 2. 3, 2, 1. Again. Here. I'll put like right here. And this.
Better.
All right, now. All right, let's go. 3, 2, 1. Unfortunate.
Yeah, that's a bit better.
Here, okay. Well,
Just put it on the old spot. Because I know where I threw it from.
here.
Yeah.
All right, take 4. Fourth time's the charm, obviously. 3, 2, 1.
You're kidding. It'll happen eventually.
I'll put it right here. Okay.
Good.
Yep. This pot has paid.
How can we realize?
Pot has now been unlegalized. Let's go. Yes. All right. Anything else? Want to do another pot, or I think we have enough footage, honestly. Excellent.
No, that was terrible.
Fine. Take 2. I'll get it from this angle. Oh my. That launched. Oh, we're getting closer to a circle though.
Mm-hmm.
Oh my. Look at that. 1.
Makes a funny sound.
Makes a funny sound. It does. Let's get a closer look.
It's a funny sound.
Very much a funny sound. Nothing?
No.
That is. Oh. We can make some good music with it though. Ooh. Wait.
That's just this guy. He's cool.
That was good. It went into the ground. Excellent.
I got the ground there. You can feel it. It's the cubic.
Oh my. Oh. You seem to have missed. Let's do that again. Dang. Let's try that again. Oh, there we go. Is this like Charmin?
I have no clue.
Oh,
I think it's like Scots or something.
dang.
don't know,
It's really taking a beating. Again. Go. Oh.
So if you just drop it like this, I don't think it does anything but feel it. Because I wonder if you get a corner. Is the idea.
No.
You just need to throw it.
Not even. Oh, wow. The count. There you go.
It's so much funny when it just goes through.
1.
This thing definitely broke through the. Yeah. No. Cube is taking battle scars.
Oh no. 1. Go.
And despite the fact that we were unable to test tungsten in the lab, we had a much easier time testing netherite.
Alright, so when testing stress and strain for netherite, the process a lot more simpler, a lot more streamlined, a lot more controlled. So what we're doing here, I've set up an experiment to test the durability of uh, a full set of netherite armor. And first things first, we have I'm equipped in full netherite. And then next thing we did was we spawned in a zombie that has a netherite axe, as you can see here. So this zombie, uh, this zombie is going to hit me uh, repeatedly until I die. But then once I respawn, I'm gonna put on my armor again and get back in, and then zombie's gonna keep hitting me uh the until all of my armor here has been destroyed. All right, that's pretty much it. Until all the durability of the armor is gone. So that's why I have this here, so that when I die, I can instantly respawn, come get my stuff, and it makes it as streamlined as possible. And you can see the zombie is in a 1x1 area with the fence blocking it, as to make sure it doesn't escape, and that it can only hit me and like can't come after me and stuff. So yeah, and then I'm gonna repeat this experiment, counting the number of times the zombie hits me until all of my armor is gone. And then I'm gonna take the number of hits it takes for the zombie to destroy the armor, and divide that by the number of ingots it took to make the armor, which was 24, in order to find the average durability of a single netherite ingot. And we can also use stats from the wiki and other sources to help find the values and like compare it to the real world, like make connections and put it in units that are real world, so we can compare it to the stress strain of tungsten. So yeah, let's get started with that. So let me make sure everything's in order here. Good. Yeah, let me make sure my let me show you. Let me go into survival real quick and make sure that I have. Oh shoot. Let me go into survival real quick. Make sure I have all my hearts, because I do not want to restart this. Okay, I have all my hearts. Good. Let me go back into creative. Game mode. Creative. Cool. All right. I respawn. Respawn point is set. I have glowstone in here to refill this, how many times I need it, and I think I'm ready. All right. Countdown, countdown. Let's get started. Okay, game mode. Survival. Okay, 3, 2, 1. 1, 2, 3, 4, 5, 6, 7. Alright, now let's get this. Let me get the armor. So I want to see out of range. Careful. And now I'm going to re-equip the armor. This, and this. Okay, so it was like, yeah. And let's go again. I think it was 7, yeah. 1, 2, 3, 4, 5, 6, 7. Okay, so 14 now, 14, I believe. Yeah, 7. Okay, open those. Right. Okay, this. Oh my god, this is not good. I'm just gonna read it. Alright, let's read it real quick. Game mode, creative. Alright, I need to get this. Alright, cool. I get some bedrock. Real quick, bedrock. Let's build. Oh shit, I need the rock. Alright, oh, here it is. Right. There we go. I'm just gonna grab all of the rock. There we go. That's it. First. Throw it here. There we go. Alright, this. That was it. Oh shoot. Didn't tell me. Alright, I think it's fine. Yeah, we're good. Alright, so I'm guess I was here. I'm going to game mode survival. Okay, I was at like 14, I think. Alright, I hit 1, 2, 3, 4, 5, 6, 7. Alright, so 7 each time. So that's nice. This is I know the number is 7. So that's plus. I'm gonna refill this. So right now I'm 21. So it does look like the zombie killing something. So I can just keep going until everything's up. So let's go. 1, 2, 3, 4, 5, 6, 7. So again, yeah, what was the number? I'm already dying. Alright, where's my hands? There we go. That. 1, 2, 3, 4, 5, 6, 7. So again, what a nice number. There. There. Alright, my head. 1, 2, 3, 4, 5, 6, 7. Alright, nice. So there. Okay. I was thinking really starting to go down. So right now we're at 35. Oh, yeah, we're 35 now. 35. Okay, let's keep going. 1, 2, 3, 4, 5, 6, 7, 42. Oh, we do need to charge this though. Let me charge this. Quick. Okay, I'm gonna charge this first. I do die. I do not want to go back to the real stuff. That's too much time to waste it. Grab this one. Alright, but 1, 2, 3, 4, 5, 6, 7. Alright, so yeah, what a nice number. Alright, so that range. Yeah, there is a damage reduction, as you can see. significant damage to helmet, boots, and pants as well. Alright, so now we're at 49 minutes. Alright, 1, 2, 3, 4, 5, 6, 7. Alright, now we're at 56. Keep going. Alright, 1, 2, 3, 4, 5, 6, 7. Alright, cool. Now we're at, look at that. Can we refill this? Alright, what is that? No, that's alright, that's creative. Okay. Game mode. You're right after, P6. Yep, P6. Game mode, creative. Yeah. Alright, now I can get this. Alright, that's good. We're gonna get some of this to patch up. So P6, P6. Sorry, P6. Very much memory game anything. Another game. We're fine, whatever. You can get it done. Right now, so back to survival. Slash game mode, survival. Cool. Alright, so exit. Okay, so exit. Alright, so exit. Let's see, we're at P6. Let's keep going. 1, 2, 3, 4, 5, 6, 7. Alright. Alright, so got these. We're at 63 now. 2, 3, 4, 5, 6, 7. Alright, cool. We're at 7 now. 7. Yep. Alright, almost there. Getting close. Really close. The helmet's almost done. Let's start halfway. Same thing. Alright, let's keep going. We're at 70. So yeah. 1, 2, 3, 4, 5, 6, 7. Nice. Alright, got these. That's not like it's free again. Okay, give me a second. Do you bear with me? This is very very intensive. If anything. Game mode creative. Alright, cool. Now let's look at those lanes. Make sure those. We're gonna fill it up. Wait, we're getting there. It's getting close. It's all about the experience process. Anything. I'm sure they'll be playing experiments for this one. Not be, but we have these last experiments. Alright, okay, I'll get this way then. Here, I'm gonna go into game mode survival. Alright, oh, let's back to it. Alright, now we're at 77, I believe. Yeah, 77. 1, 2, 3, 4, 5, 6, 7. Alright, now we're at 84. Those really quick. Alright, 1, 2, 3, 4, 5, 6, 7. Alright, now we're back to. Here it goes. Alright, that's just like, not just a helmet. Now we're at 91. I believe, yeah, 91. Okay, game mode creative. Honestly, I might just like make a little thing here. Okay, just again, like just grab the what I need to. If it's not get hurt. But you never know. I'll leave that there for now. Okay, I'm gonna go here then. Alright, this is just another how much Alright, game mode, survival. Alright, next we're at 91 and counting. 1, 2, 3, 4, 5, 6, 7. Nice. Alright, reveal this. Alright, we're at 98 now. 98. Alright, oh, that how much on this? Just going up. I mean, that's how much on this? Yeah, that's usually done way more on then. But yeah, alright, we're at 98. Let's keep going. 1, 2, 3, 4, 5, 6, 7. Alright. Alright, oh, just let's see on the other side. So we go that. See in here. Alright, ooh, let's go. But I'm just leaving that. Alright, let's keep going. We're at 105. Yeah, 105. Alright, let's keep going. I'm definitely track across. Maybe I lost track. I don't know. Let's go. 105 and counting. 1, 2, 3, 4, 5, 6, 7. Alright, and even if I lose count, number of times that I go get hit by a zombie, because I know sometimes it takes to kill me. So every time I go like this close after the video, and see how many. And then I will correct anything any errors in the India analysis for after this experiment. So let's go. Now we're at 112. Let's go. 1, 2, 3, 4, 5, 6, 7. Alright, we're gonna reveal that. We'll reveal that, and I will get the boots. Oh, the helmet's also on though. Ooh, I probably done more often. I'll go 87 then. So I remember that. It's probably counting. Oh, well, yeah, the boots still there. But I have the helmet's on. Alright, cool. I was very close. But yeah, after the helmet's on though, I should probably counting is gonna be a lot more important. But yeah, alright, let's go. We're at 112 or 119, I think. I think I'm gonna say 119. So 119 and count. 1, 2, 3, 4, 5, 6. Oh, 6. Alright, okay, so the helmet's on. Those appear to be the helmet seems to have broke in the middle, which is very interesting. So we got this. Thank you. Alright, so we got helmet, which is 5 so 6. Alright, so 19 plus 6, 225. Alright, that's just that's 125. Alright, I'll see what that. 1, 2, 3, 4, 5. Oh, 5 now. We lose the boots. Oh, I'll get no lose the boots. Over 5. Alright, see that. I'll broke away. That's what we're 5 now. Okay, so 135. Alright, so 1, 2, 3, 4, 5. Alright, 1. Alright, 135. Yeah, we're 135. Alright, cool. Where's the pants break? Okay. Here, I'm gonna refill this first. Alright, cool. Wait, don't tell me the pants broke, did they? Oh, yeah, what? Oh, yeah, cool. Boots are next though. Boots, pants, and the so let's keep going. 135. 1, 2, 3, 4, 5. Alright, so 140 now. Let's keep going. 1, 2, 3, 4, 5. Nice. Alright, cool. The boots are almost on, which is interesting. Only a few minutes around, so this is actually really consider the viewers, but yeah, this is extremely done for everything, I guess. Yeah. Alright, we're at 140, 145, 140, 145, 145. Oh, I can count. I post after this. Alright, let's go. We're still 45 minutes. Wait, 1, 2, 3, 4, 4 now. Okay, that one broke. Oh, the boots break? Oh my. No, the boots broke. Crazy. Alright, I almost got the last one, just literally. Alright, 4, right? So it's like, we're either at like 140, we're either 149 or 145. I'm just 149. I can always put that, and I will let you know if I got something wrong. But yeah, anyway, so 149, 1, 2, 3, 4. Alright, there we go. Alright, that's right there. Alright, cool. A few more hits, I believe. I believe at least. Alright, we're at, we're at 153. Yeah, 153. 1, 2, 3, 4. Alright, 4 skill. This on. Oh, this one. Okay. We're at 157 now. 157. 1, 2, 3, 4. Okay, we're at 1. Thank you. We're at 160, 164. No, no. Sorry, 161. 161. 161. That's right. Alright, 161. Almost there. They're really so close. So close. No streets. Almost 160. Alright, yeah, 161 and counting. 1, 2, 3, 4. Nice. Where's the right there? The pants are on though, which is so go up, figure out the pants on, and then full suits. Almost done, almost done. 165. 1, 2, 3, 4. Alright, so 169. 1, 2, 3. Oh, 3. Alright, pants are on. Oh no. Alright, so 3. So it's 172. 172. And counting. 1, 2, 2. Oh, I missed 2. Oh, it's pants holding 2 now. Dang, let's do this now. That's crazy. I guess that's really that's on these. Let's get up to really let's get to show how strong the rate is. Like it's crazy rate. Take a lot of hits from the rate. It's insane. We're at 165. 165. Alright. Oh, sorry, I was endurance test amazing. 1, 2. Oh, 3. Okay, alright. 2. Yeah, oh, there we go. 174. Never mind, I apologize. 174. Now we're at 1 shoot, 174. What's inside? Okay, alright, keep going. 1, 2, 3. I don't know if I have to do this. Oh, sorry, maybe. That's interesting. That's secrets. Alright, well, we're at 170 what's it? Oh, wait, wait, almost there. 1, 2, 3. Oh my god.
Is it gone? Oh my god, I think it's gone. I think we're done. Took 3 hits. It did take 3 hits. It did. And I think the arm. Is it gone? It is! Oh my goodness. It's gone. The chest plate has been destroyed. Oh my goodness gracious. It's gone. Oh, it's over. It took 183 hits to do that. Approximately. There's definitely human error in there. But I will go through the video. I'll go through this and I will make sure. See if anything is wrong. But as of now, it seems that it's 183 hits from a zombie with an unenchanted netherite axe that kills a player in fully netherite armor. And now we can use this to find the durability of one netherite ingot and compare it and convert it into real world units, which I will do in this next in the following clip. Right? Yeah.
Alright, so now that we have our data, let's analyze it and let's find the uh, durability of one ingot of netherite and uh, compare it to the real world. So then we can compare it to tungsten. Alright, so first things first, let's write down the data we got. So it was, well, when I went back through the footage, I saw that I did miss a few hits. Uh, it was not 183, like I said in the video, but rather 198. So I missed a few hits. I missed a few hits, but whatever. Anyway, we have that. That's what we have down. And then for the netherite chest plate, netherite chest plate. That's here. Let me expand this box. Nice. All right, there we go. Netherite chest plate was supposed to be 592 durability, and then the 8 netherite ingot netherite ingots used to make it used to make one chest plate. All right, so that's what we have. All right, so that's what we know. 528, 98, 592 durability, 8 nether ingots used to make one chest plate. Good, we have that. Now let's find how much one hit, how much durability one hit took off. So all we have to do for that is just divide this. Oh, there, let me enter. 592 divided by 198, which is equal to that's equal to 2.9898989899 2.98 durability per hit. I spelled durability wrong. Durability per hit. I believe that's right. Um, I think. Let me make sure. I think that's right. That is not right. I added a. There we go. That's right. All right, and that's how much one hit from the axe did to the chest plate. All right, we know that. Now, how do we find what one? So we have that, but how do we convert that into like the like real world units? Well, let's just use whatever connections we have game, and the best one is the diamond. So let's see here. A diamond chest plate. Diamond chest plate is equal to is 528 durability. All right, and then 8 ingots as well. 8 diamonds, not ingots. 8 diamond used to make one chest plate. All right, nice. And now we can just do, and we know, and then we using real world measurements, we know that one diamond stress stress slash strain uh, resistance is measured at 600 gigapascals, which is insane. That is an insane amount of pressure needed to break one diamond. So yeah, now we have that. Now we can just take this. We can just take, so let's find it for one diamond. So find for one diamond, just take 528 divided by this to find 66 durability per diamond. All right, we have that. So that's the durability for one diamond. And then that we have that, we can take, we can convert the gigapascals into into like into durability or durability into gigapascals. So to do that, we would find how many gigapascals are in one durability unit. Let's say so it'd be three. So it'd be 600 divided by 66, which equals approximately 9.090909091 uh, gigapascals per durability unit. Alright, now that we have that, great. Now we can use this. Well, that's our, yeah, that's That's how many gigapascals are in one durability, which is great because now we can just use this with the we have with with the numbers we found above, specifically the durability per hit, which is 2.9898 repeating. So we can take this here, that there, and then multiply this times this, take this and that, and multiply that, and then we get a number. We get 27.1800. Oh no, not 00. One, plugging it into the calculator. 27.180. Give me a second. It's being weird. There we go. 89991. There we go. And then that's that's gigapascals per hit as the durability units cancel. So now we have that. Now we just have to take the number of hits and then multiply that by this number, and then we have the durability and like the amount of stress or strain needed to break one netherite chest plate, and then we can use that to find the single netherite ingot. So we have this. We take this number here. We take this there, and multiply that by the number of hits, which is 198. Does that equal? And then we get approximately 5,381.818182 gigapascals. And this is for I believe this is like yeah this is to break one. This was to break one chest plate. So we have that. That's for like 8 netherite ingots, or just one chest plate. Yeah. So now we have that. We can just divide this number, take this number, and divide it by 8, and then plugging that into the calculator, we get, here, give me a second, you get a number, we get 672.7272728. Oh, that's 62. Excuse me, my bad. There we go, 72. All right, nice. And then that's the pressure or stress strain needed to break one netherite ingot. Yeah, and now we can compare this in their conclusion. We can compare this data we found to the uh, real world units of of tungsten, and see, like, compare that and see which one is stronger, which we will do in our conclusion. So let's jump to that right now.
So what did we learn? When looking at the results, it's clear that netherite absolutely demolishes tungsten in strength, as netherite has nearly double the thermal resistance of tungsten and orders of magnitude more resistant to stress and strain than tungsten. While there was most certainly human error throughout the experiments conducted, such as counting errors or incorrect measurements and such, the disparity between the two materials is not solely caused by human error. There must be a clear-cut disparity between them because one material, netherite, is stronger than the other, tungsten. Human error would not be the only factor for why this comparison is so lopsided. Clearly, netherite surviving the intense hellish temperatures in the nether prevails over tungsten, proving that it is the strongest material out of the two. But hey, that's just a theory. A game theory. Thanks for watching.